You've seen yourself that the spread of different terminology, different architectures, different limitations, different constructs in each of those clouds that we have touched on is big. I mean, everything is kind of similar, but it's different. It has some analogies in the on-prem world, but again, it's not something that you can pick up just if you've only been working in the on-prem world. You will need some learning to go into the public cloud, and if you want to become an expert in each of the ones we support, and the popular ones, it will take some time. So. That's one way of doing that. If you want to do a PhD in each and single cloud, yeah, great stuff. I'm sure you'll be well off. But we have a slightly different approach. What we define is like different eras in the cloud world. So I would say we've had Cloud 1.0 up till 2014. Early days of the public clouds, and people were not really knowing what they were doing. They were trying things out, making them work somehow, and without thinking the architecture through, without doing any automation, with the mindset of, okay, let's get it working, and we'll worry about all the rest later. Okay, and then came Cloud 2.0, probably last 5 to 6 years. People were more and more aware about the cloud deployments. They would go into one cloud of their choice. They would either do things manually if there were not too many things to do, or they would start automating, do some tooling around it. But again, when they realize that they may need to move to another cloud provider, they would need another set of tools, another set of automation. It wouldn't be as easy. And then today we are arriving at Cloud 3.0, where companies are realizing that public cloud is multi-cloud. You cannot just focus on one single cloud. You have to be ready. That's your strategic decision to be multi-cloud. Sooner or later, you will need it. So now we're talking about automating everything, having good visibility, having good control, all across the board, all across the popular clouds that you may go into. Sometimes when I have some more time, I do this analogy. Cloud 1.0 is like building a tree house out of wood. Okay, it's nice, it's quaint, you can make it work, but it's all manual work. And if you want to replicate it, it's the same work all over again. Cloud 2.0 is like building a modern house. Okay, you have some prefabricated elements, you can have some power tools help you with it. But then if you want to move to a brand new country, you will probably not take those tools with you. They may be different regulations, not allowing you to build the same way you did in your original country. So lots of limitations. And Cloud 3.0, that's what I see as the future. There's like 3D printed houses. And sorry for that analogy, but recently I have purchased myself a 3D printer for my flat and I love it. So I guess this is just how the ideas come through. So Cloud 3.0, everything automated. And you need to think through the entire model. You need to have this architecture ready to start deploying. Otherwise, you cannot even start building. First, you need this model, this architecture, and only then you can start deploying. And this is exactly what Aviatrix sits. We have spoken about lots of challenges in the public cloud. So first of all, each of them is kind of different. Then we spoke about the go build mantra. You have to do everything on your own. And what Aviatrix believes, automate, orchestrate, and abstract, so that you have a single way of managing and building inside all of the clouds, fully automated. Each cloud would tell you they are the best cloud, and you will never need any cloud again. We know that's not true. We want to be multi-cloud ready. Each cloud is a black box. If something breaks on the networking side, you have no visibility into what's broken. You can just nicely send a support ticket and wait for the resolution. And you're just one of those people in line, and those enterprises in line trying to regain their services. We say, no, we want to be in control of our networking and security. We want to handle all of it on our own, because if something breaks, we want to have we won't have all the tools to fix it. And we want to have visibility and monitoring all the time. And trust. All the cloud vendors will tell you, okay, trust us, we're safe, we're secure. We know, like we've been talking about ExpressRoute and Direct Connect and Interconnect, none of them is encrypted. So is that really secure? What happens on the cloud backbone? Is this something you trust? If one VPC talks to another VPC, do you want that traffic to be encrypted or not? Do you trust the cloud provider or not? Do you have a zero trust model in your enterprise? We believe in zero trust model. We say encrypt everywhere, secure everywhere. And having all of that in mind, we came up with this cloud agnostic reference architecture, multi-cloud network architecture. And nobody has done it before in the world of the public clouds. You've had so many examples of those architectures on-prem. So just flagging it here. You had many examples. You could just copy and paste it in your enterprise. Easy. Nobody has done it in the public cloud yet. And without the architecture, you're just like a child in a sandbox. Okay, you're putting things together. It will work, but this is not enterprise grade. This is not enterprise ready. If you want your critical business to run on a good networking architecture, you want to build it having a big picture in mind with the right architecture. And this is the architecture that we are proposing. And as you will see later on through that presentation, you will see what challenges we are solving with this architecture. The biggest piece here is the global transit layer and application layer. We can group it together in Cloud Core. So this is the way how we make sure that all of your resources in the cloud, whichever cloud they are in, they can communicate. Then we have Cloud Access Layer. This is how we connect all of your external resources, extranet, public internet, ingress traffic, your partners, branches, data centers. This is where you would be terminating all of those, all of that connectivity. And as you are getting ready to be multi-cloud, you want to make sure that all of that architecture is unified. You don't want to do 10 different things in Azure, another 20 different things in AWS, and something even different in Google. That's not scalable. That's not how an enterprise should be working. So we provide you with this architecture, how to deploy everything in a unified and centralized way. The same common access network, the same transit network across all of those clouds. And then what spans across all of those layers is the security. As I told you before, zero trust, this is the model that we follow. We want to make sure your traffic is safe, regardless of whether you believe that the cloud backbone is secure or not. We just want to be double secure. And if you need to insert a firewall, we also have ways of doing that. We have great places, great architecture, great model to insert that firewall for you. Third-party firewall, whichever vendor you would prefer. And then we have this operations piece where we centralize all of the functionalities of management and visibility and operations in our platform. If we were to look at it, and this is something that you should now be familiar with. I mean, you've been hearing about it for an hour and a half. So you have VPCs, you have VNets, VPCs in Google, another region in AWS. Those are your clouds that you're using. Now, for you to interconnect them all, we propose one unified transit layer where we will actually, over here we're talking just architecture. So let's abstract a little bit now away from Aviatrix, but this is the right architecture. You have your networks, and that if you add a new network here, it should by default have all the connectivity to all of the other resources, or at least it should not be difficult to get it done. You should just hit a button and ready to go. You should not have to go into any other element to update anything else, because it's like a domino effect. You change one thing and suddenly you have to change 100 different things. No, this all should be centralized. It all should be automated. And then the layer that actually resides here in the middle is responsible for making sure that all the traffic gets to the destination. If you want to insert a firewall, yeah, great. This is the best place to do it. It's hanging off of the native constructs or residing in the transit VPCs that we would be proposing in the architecture. That's the best place to secure that traffic going between your networks. And finally, we have the access layer. This is how you would connect your data centers, customer sites, maybe SD-WAN solutions, third-party VPCs, VNets. Lots of good options. We have thought this through. We have worked with many customers to come up with this design. And I'm pretty sure you have not thought about public cloud networking in those terms, but this is the right blueprint to follow. So we have already spoken about lots of things, and we will still keep on telling you more and more. But what I want you to realize and have really well burned in your brains is that transit network, this is the key element of your public cloud infrastructure. This has to be multi-cloud ready. Otherwise, sooner or later, you will run into challenges, into limitations. So transit network, this is what actually Aviatrix specializes in. But we want to make sure that whatever tools you will be using to build your networking, make sure transit network is super reliable, super secure, potentially encrypted everywhere. So this is the model we're proposing. You have the layer where you manage everything. It should be centralized. Even if you have 5 different clouds that you're using, there should be one place where you monitor all of them and you troubleshoot all of them. You need to have tools to verify the correctness of your network, that there are no offsets of the intended configuration of your networking. Thus, security all the way through, different ways of connecting to the cloud. But transit networking, this is the heart of the architecture that we're proposing.